Hello, my name is Bogdan, and today together with Lucia we're going to present a paper for Data Science 2 class by O.Blanchar and R.Perotti from 2002. This paper studies the dynamic effects of changes in government spending in taxes on output over GDP, in other words, by applying some structural VAR models. The reason we chose this paper is because we really wanted to do something in the macro field, and there it's rather hard to apply some classical data science approaches where one would have some training and testing data and would evaluate trained model based on some metrics on the testing data. But what VAR models actually allow us to do is that they allow the data to speak by itself without assuming any special relationships between the variable, and this is more data science approach in our view. So again, the main motivation of this paper is to study how the shocks in fiscal policy and shocks to taxes affect the output, affect the GDP. This is very important for macroeconomics, obviously, as there is this very long debate between neoclassical and Keynesian school of economics thought, where they actually present very different views on what should happen when government starts spending more or government increases taxes. So resolving this problem by looking at what's actually happening when these things happen, by using some empirical data and empirical relationships is very important. So additional contribution that this paper has is that it resolves some problems that previous research had in identifications in data and some statistical properties. The authors argue that applying VAR models to fiscal policy is much better than applying VARs to monetary policy. It's because fiscal policy is rarely used for output stabilization. It means that shocks to fiscal policy are more exogenous and allow for better statistical properties, and that also fiscal policy is very lagging compared to monetary policy, and the legislators cannot really implement stuff really quickly, and it adds in some statistical properties, making shocks more exogenous. So additionally, we'll be interested in some effects on investments and consumption and trade by adding these shocks to fiscal policy and taxes. So let's talk now about the methodology. But first, I want to talk a little bit about the data the paper used. So the data was mostly focused on the post-war US economy from 1947 to 1998. They used quarterly data. All the variables were in real and per capita measures. All the variables were also seasonally adjusted using some end biased filter, which will show some problems as will be discussed later. So the basic, we have here the basic VAR specification, the main equation of first reduced form of VAR, where as a dependent variable we have this vector of three variables. We have taxes, government spending, and GDP. And on the right hand side we have some distributed lag model of the lags of these dependent variables. The authors used mostly four lags here. All the variables were also transformed to logarithms for better properties. Additionally, to this equation were added some dummies for some big jumps that were seen in the data, some big jumps in taxes and fiscal policy, which are not really usual in that respect, and that they can make some additional statistical effects. And finally, we have some reduced form residuals, which are some of the structural shocks to each variable, as is shown below here. So the main problem for the authors is to identify this equation to have proper contemporaneous effect. So obviously we want in the GDP equation, the last one, we want these coefficients to be estimated, and this makes some requirements on the coefficients in the above equations to be set somehow, so that the statistical properties are are satisfied, and we do not have correlation between the independent variables and the residuals here. So the first assumption that is made is that this beta 1 coefficient is equal to 0. This is due to the fact that fiscal policy cannot react to GDP really quickly in the same quarter. So we can safely say that this coefficient is 0. As I said before, that fiscal policy has some lags in the implementation. This coefficient alpha 1 is estimated using some elasticities, how taxes adjust to GDP contemporaneously. And the last thing that's needed some attention is that is these two parameters, alpha 2 and beta 2, and the authors actually consider two different variations of the models, where they choose either alpha 2 is equal to 0 or beta 2 is equal to 0, since it is not really easy to say how contemporaneously taxes affect government spending and vice versa. So by that, the identification of this model can be achieved, and all of the coefficients can be estimated. And at the end of the day, we are interested in the impulse response functions. When we add some shocks, some exogenous shocks to taxes and fiscal policy, and we see how the GDP and its components react. As I said before, the authors used two different variable orderings, either taxes ordered first or taxes are ordered second. This is these two coefficients, as I said, so either of them can be 0, and at the end of the day we'll see that whether we choose alpha 2 equal to 0 or beta 2 equal to 0 will not make many differences.
Moving on to the results of the paper, the analysis of tax shocks reveals three key findings. The first being that the authors find that increases in taxes lead to a significant reduction in GDP, highlighting the contractionary effects of taxation on overall economic output. Second, they find that private consumption is crowded out by taxation, as higher taxes reduce disposable income and consumer spending. Third, while investment exhibits smaller response compared to GDP and consumption, it consistently shows a negative reaction to tax increases. Also note that the authors examined the effects of the tax changes using both deterministic trend, where the effects of tax shocks are temporary, and a stochastic trend, where the effects are permanent, leading to lasting changes in economic variables. Moving on to the analysis of government spending shocks, we find that the other authors find that increases in government spending raise GDP, reflecting the stimulative effects of fiscal expansion on overall economic output. Next, they found that private consumption increases, suggesting a crowding in effect, where higher government spending boosts household demand. However, investment declines, indicating a crowding out effect, as government spending competes with private investment for resources. To check the robustness of the results, the findings of the paper remain consistent when using alternative variable ordering and elasticities. The effects also hold under changes in assumptions about co-integration. However, a major limitation is that the analysis assumes that fiscal shocks are unanticipated, which doesn't fully reflect real-world dynamics. Valerie Remy, in her paper Identifying Government Spending Shocks, It's All in the Timing, argues that Blanchard and Perotti's VAR approach misidentifies government spending shocks because it assumes spending is predetermined within the quarter, failing to account for the anticipatory effects of fiscal news. Remy argues that even though Blanchard and R.Perotti tested for the problem of anticipated policy by including the future values of the estimated shocks to determine whether they affected the results, and found that the response of output was greater once they allowed for anticipation effects, they did not show how the responses of consumption or real wages were affected, and instead Remy proposes the use of narrative-based shocks, which capture timing more accurately and shows that VAR shocks are Granger-caused, leading to biased results such as the omission of consumption and wage declines when fiscal policy is anticipated. In conclusion, the author's findings underscore the significant but nuanced effects of fiscal shocks on GDP and its components. Spending increases while boosting output come with trade-offs such as the potential crowding out of investment. On the other hand, tax increases consistently lead to reductions in output and consumption, highlighting their contractionary impact. However, as later critiques by Remy pointed out, the robustness of these results hinges on the proper identification of exogenous shocks. For data scientists, this debate highlights how careful data design and model validation can lead to more reliable insights. And finally, these are the two main papers which were used for this presentation. Thank you for your attention.